Hey folks, Sega Sonic fan back here doing the Laseractive Repair. And I got the microscope out and everything. This is the daughter board. It's got some of the Sega CD audio mixing circuitry and some other goodies. And what I'm looking at here is some corrosion on one of the ICs here. And see if I can pick this up with the camera. This is what the pins should look like. Nice and clean. Nothing in between each of the pins. You can see the green mask there. And over here there's just a ton of sort of white goo, kind of looks like spilling out in between all the pins. And that's corrosion from the leaking electrolyte from the old capacitor that was here. This has actually been recapped now, but the person that did the recap didn't actually clean up what the old capacitors leaked out and the problems that they caused. So that's what I'm working on here, and there's a couple of chips that have been affected by this. Now keep in mind, this isn't terribly bad corrosion like you get in the Sega Game Gear where those caps leak like just totally crazy. But if we look over here, there's a little more corrosion on these JRC chips. These are dual op amps, by the way. These are used in a lot of audio hardware from the 90s, even up till today. You see some of these, and they're okay. I like to replace them with better ones, as I was mentioning. But there's also a couple repairs here. You can see the green wire repairing some of the traces that were damaged when this thing was being worked on, and some Kaplan tape to hold it in place. These repair jobs look decent. I don't think I'll actually change them. They're using high gauge wire, even though this particular trace doesn't seem to call for it, but that's okay. They seem like they've done a pretty good job with that, actually. And overall, this recap's very nice. I gotta say, whoever worked on this did a pretty stellar job as far as that goes. A couple of these are crooked, you know, but like that one's a little crooked. But you know, there's like 80 caps in here or something. I can't imagine how much time that took. It must have taken a while. And I'll go ahead and show you the main board here, just kind of to get an idea of what it looks like under the microscope. These are the pins you really want to examine when you're repairing these, by the way. This is the Sega CD ASIC right here, 3155632, and this is a TPFQ. Gosh, I always get my packages. Trying to remember the package type for this. TQFN-144. Actually, this might be a 200. Yeah, these are a 200. Anyway, very fine pitch QFN package here. And you're looking at, I think this is TSSOP spacing. So this is a 0.065 millimeter pin spacing. So that's very, very small. And it's very easy for gunk to get stuck in those pins and little shorts to happen, and that'll cause you all kinds of issues. The other thing is I went ahead and reflowed these pins here over on the I think is the PCM chip, the LC8951. That's either a DAC or a PCM. That one had some corrosion from that capacitor right there, C4, I believe is what that's labeled. And or C40 actually, shows you how many caps there are on this thing. And of course there's the battery replacement, which is another issue as well, and that goes here. Person put a CR2032 in here, and they also put it on top of the ASIC chip. Like they had it mounted like that, like so. And I don't know, I don't feel comfortable putting a battery over an ASIC like that. It's probably fine, but if it does leak, you really don't want it to go. These are your most fragile chips and the hardest to, well, I don't know if the hardest to replace. This Pioneer chip's probably the hardest to replace, but you know, I don't know, I don't think a battery should be anywhere near a very important IC. The X68's far easy to replace, and this area holds it a lot better. I'm also going to insulate it more, and I already did insulate it a little bit more. The other issue though is this is a CR2032, and I'm going to double check this, but pretty sure all the Sega CD models use a rechargeable lithium battery. CR2032 is not rechargeable, so that could give you some issues for sure. I'm going to double check on that, but I'm almost positive. The CDX, which uses the same chipset as this, does use a rechargeable lithium battery, and that's, you know, for a longer life and everything. It makes sense because it's not user serviceable. It's not like the Sega Saturn, which uses a CR2032, because you can change it. There's a spot in the back to change it. This is a little different. But yeah, a little overview like I was doing before. Here's your BIOS chip, which is nice and socketed there. These are your SRAM chips. This section here is the Genesis portion of it. So there's your VRAM right there. There's your 315-5660, which is also in the CDX in some models of the Genesis 2. Obviously, these are your two controller ports. And middle here, this is this really cool Pioneer chip. My guess is that's for the Mega LD interfacing, in conjunction with this chip, which is probably a PAL. Oh, it is a PAL. It even says PAL on it. We'll zoom in there if you want to see. It's a PAL chip, so it's a programmable array of sorts. And then over here is your Sega CD side of things. And this is your main Sega CD ASIC. This is your 68K for the Sega CD. That's the 68K for the Genesis. And it's nice, it's interesting. It's a smaller footprint than the CDX one, actually. And then you have your various ADCs and DACs and your SRAMs and your PCM chip and all that kind of stuff. And then there's more of that on the daughter board as well. And actually, you know what? I think this is the PCM chip. Pretty sure the 3576. If I look in the service manual, that'll tell me. But you got a bunch of audio stuff going on here, analog audio stuff. You got three quad op amps, the LM324s. Those are really old. And you got some more RAM here, 2 RAM chips there. I believe those are SRAM. And 744053, 74 logic switching IC, and some other stuff going on. These are your audio op amps, more audio op amps like I was saying before. So yeah, we'll clean up some of this corrosion, and should be all working after that. Get a proper battery for this. Most likely gonna have to order that, and we should have a Laseractive that's good to go. If you do recap this in the future, anybody that's attempting this, be warned, it's a lot of capacitors. This will take you a long time to do, and it is not a lot of values, which is nice. Not a lot of different capacitor values, but it will take you a while, and you know, just be careful that you don't that you actually clean up the corrosion as well, and that you don't spill little bits of metal or other things, desoldering braid pieces, into the nearby chips on the board. So yeah, and also if you're going to recap a Laseractive, please know what you're doing. Don't do this if you're like new to doing cap replacements, because this is an expensive, very hard to replace board. This is Sega Sonic Fan signing out. Okay folks, Sega Sonic Fan back here, and I'm doing some of the reflow / corrosion cleanup work here on a Laseractive. What happens is, if you have to replace capacitors because they're leaking, that's great, you should do that, but it's also important to clean up the corrosive material, the electrolyte, that has leaked onto the board, and usually in between pins of a chip. So if you look here, it might be a little hard to see in the video, but there is some kind of white stuff around this pin here especially, and I've already reflowed 2 other chips, but this one could use a little love as well. Now there's some videos online already about good ways to do this. For example, here by the way is a really good set of pins that don't have any electrolyte on them, and if you compare the left side here with the right, it's clear that especially this area right here has some leaking electrolyte. The ones that I already reflowed, that I showed earlier in the video, move this slowly here, apologize, this microscope has some lag, but so you can see there's a little bit left there I still have to do, and I'm going to use a old toothbrush with some isopropyl alcohol to clean that before I reflow it. And then here's one of the ones I reflowed already, and you'll see it's kind of dark right there right now because there's a lot of solder flux that has been left behind. So let's kind of give that a good little, let's give this board a little isopropyl toothbrush clean here. And you won't be able to see this in real time because this microscope I'm using does have some lag. It's not a very expensive one. One of these days I'll get like a Patreon account or something and people can donate for me to get better materials if people want to, so that I can make better videos for people. But in the meantime, my budget is modest and I have to settle for what I got. So doing the toothbrush cleaning. Sorry, I'm not actually getting this on camera. Not that we really need to see what a toothbrush rubbing against pins looks like that much. But yeah, that's pretty good there. Pretty good there. And I'm going to put on my ventilator mask, so it might be hard to hear me, but I'll try to speak up. So now that it's all cleaned, put my iron on the sponge, clean off the tip. Make sure you keep your iron tip really clean doing this because all the electrolyte will mess up your soldering iron tip as well. And then just go over each pin there. And the heat itself will burn off the alcohol, and as well as some other chemicals. That's why it's important that you have a mask doing this, because it is very toxic. And so yeah, that side's looking really good. If it's a little dark, that's not a huge deal. That has to do with the rosin, and it's actually a lot darker on camera than it looks in real life. Let's see if I can actually put up the microscope light. See if that helps at all. Yeah, not too much. But yeah, the point is you don't have the white chalky residue, which is the leaking electrolyte in between the pins. So this one actually looks quite decent with just the isopropylene alcohol cleanup. But I'm going to go ahead and just run over this again. For anyone out there looking into tools and good soldering irons, a good soldering iron is worth its weight in gold, and a good soldering iron tip as well. When I was starting out, I invested in a lot of the wrong equipment and didn't want to spend money for good equipment. But if you're interested in doing this kind of work, I highly recommend getting a good soldering iron with an adjustable temperature range. The iron that I've used for the past 10 years, which is very decent, it's still in production, is the WESD 51 by Weller. And this is the long pencil conical tip, which is very good for fine work. And it'll run you, you know, about $150 to get one of these. Maybe a little more depending on shipping. But it's going to pay for itself in the long run. So those are the GRC op amps, and those all look pretty good. And the last culprit, I'll go ahead and take a look on this analog board here, is you can see this one's got some very minor corrosion, but the whole set of pins might as well, while I'm in here, do the whole set. I like to do a thorough job just because, you know, this thing probably isn't going to get touched again for another 10 years with any luck, right? You know, this thing's been recapped and worked on only once since 1993. It's now 2017. So let's give this a little TLC, and then you know, a job well done is a job you don't have to go back to. So I'm going to do a couple more pins here. And I'm applying a little bit of solder to some of these to get it reflowing a little better. I could use more flux, but using fresh solder is also good too. And there is flux in the solder.
as well. Now these aren't picking up super well because of the corrosion, so I actually am going to put a little more flux on here. Just a tiny amount. And you'll see how that smoke there and kind of it's kind of making a popping sound, a kind of fizzy sound. Some of that's from the flux, but a lot of it's actually from the leaking electrolyte, because getting a lot more smoke and a lot more of that sound than I usually get. And it's just really obvious because of now how easy it is to reflow this thing. After cleaning it, getting some flux on it, and burning off the... yeah, so now I don't need flux at all because it doesn't have the leaking electrolyte on it. And this is probably the last one. Oh yeah, you can see it right here, this area. My guess is that leaked from this guy down to there. Someone has previously recapped this, and so I'm just cleaning it up because it wasn't working after the recap. And the person who did the recap, I guess, didn't know why. And this is a big part of it. Is that a lot of the leaking electrolyte wasn't cleaned up around the chips themselves. Let's see if I can center this more. Apologize for the video quality. Alright, so it's looking pretty good. I'm going to go ahead and now clean off the rosin and stuff. Wow, you see some of that mass came up there from the leakage. Oh, my laptop went to sleep. And there's some of it that came up over here too. You can see they put some coating on it as well. Honestly, don't think that's that necessary. I'll go ahead and put some solder on it, but I think the coating is a little overkill in my opinion. It's great though. I mean, you know, better to have good work than half-ass work. So I'm going to go ahead and just tin the exposed areas like that. And that just keeps it from corroding over time. Not that that's a huge risk. I mean, if you live in like a really salty climate, even the ocean climate that I live nearby, it's not really going to cause that. Let's go ahead and do the top of these JRCs as well, just because the bottom was looking so nasty, and we want to make sure there's nothing that got under it to the other side. Let's go ahead and put some flux on there. This is water-based flux, by the way. It's a lot less toxic. It's easier to clean up, and it's got some drawbacks. It's definitely not necessarily as effective as the other kinds, but for the most part, it does its job. For really large joints, though, I do find the other type is going to be a little better. Let's see how this one is. This one's not too bad, but I'm going to go ahead and do a little more here too. And just, yeah, looking at this board more, I'm kind of familiarizing myself with where the leakage points are. It's really good this thing was recapped because it was on its way out for sure. Should mention that to the person so they don't feel so bad. It's good to get preventative work done. It obviously sucks when your system doesn't work after the preventative work, but you know, it's a risky run because you know, circuits are complex and it's hard to know every little nook and cranny, but you can always send it to Sega Sonic Fan to get it fixed. assuming you're willing to pay for shipping, all that kind of stuff. And so yeah, so it's all cleaned up pretty nicely there. Now there are these jumper wires here. You can see one of them. Now I could replace that. It's a much thicker wire than the board chase originally used, obviously. But it does appear to be doing the job. And I don't think I think the wire is thin because it's an audio trace. And it looks like they did a good job. I mean, it's on there. This cap obviously wiggles a little bit. I might put a little bit of glue to hold that in place.
Well, let's take off my respirator. Breathing mask thing. So yeah, this wiggles a little bit, and you can see that the pad just basically got ripped up. And so the person recapping this just ran a jumper wire there. Put some Cap-on tape over it. That's all well and good. And there's, if I can get it in the microscope, I have to turn this around. Hopefully this isn't too disorienting for people watching. There's another one here, and you can see this one runs here, and then there's another one here into this cap. I've actually seen these jumpered before. I think these pads are commonly get ripped up. But again, they've done a pretty good job. You know, I could go in here and replace it, but it's not really necessary. I could do a thinner gauge wire, but it's not like you're going to get a bunch of interference or anything. And this thicker gauge wire actually holds the cap in place a lot better. So, yeah, and you can see this trace runs down and then it goes under to this pad. So nothing wrong there. There is a little bit of solder spill on this LM324 chip that I was cleaning up right here. If you can see that, it was a lot closer to the pin before. I might have actually been touching it. So get that a little bit nice and cleaned up there. And do one last inspection of the PCM chip. You always want to start with your, other than stuff that's really obvious, you want to focus on stuff that is higher pitch density, because that's more likely to create a short from the corrosive material. And some of this conformal coating stuff flaked off, went on to different parts of the board, but that's not a big deal. And so yeah, I'm just doing, the other thing is when you're doing inspections for things, try to use different angles, get different filters of light on the board. Can really help with a visual inspection. And look at the back here, there's this wire jumpered to looks like some sort of voltage regulator. It's probably like a 1.2, 1.8 volt step down type deal. And that's this thing that someone pointed out. They said it looks like a mod chip. And it's a little subboard they added because I think they made some mistakes in production. So post-production they added a board to clean up. And let's take out the main board now and make sure there's not more work I have to do on that. That's the audio daughter board. And I'm going to take a look here. I've already inspected this one and reflowed some of it. Let's do one more last inspection. I'm just going to use a magnifying glass for a second, and then I'm going to go inspect the high density pin sections. But so far everything's looking pretty stellar. And yeah, this is the high density pin on the QFP chip that 3155632, you see it right there, for the Sega CD. It's basically the brain of the Sega CD, if you don't count the 68K. I usually think the brain is the more part that's harder to replace, even if it's not technically true. Such a repair person, such a repair way of thinking. And then here's the Genesis ASIC, and just kind of running it down there to take a look at those pins. They really have to be perfect. All it takes is one little tiny piece of solder in between pins, and you have some serious problems. Very common failure area Go ahead and turn down the light here so I can see it a little better. And there is a very small speck of solder right there. Let's get that cleaned up. That one wasn't near any pins, or touching any pins. It was right near one, but unfortunately wasn't touching them. And yeah, looking pretty good. So if you look in here, there is a very, very small amount of electrolyte in between those two pins. Very small amount. And that's going to be a little tricky to get to, but we'll give it a shot. There we go. That should burn off that really tiny amount there. Use our brush, and yeah, so looks like this was recapped in the nick of time, and saved from destruction. Alright, well, hopefully you've enjoyed this video. This again is the Sega pack for the Pioneer Laseractive, and go ahead and pull the camera back so you can see the board here. And there we have it. I'm going to, by the way, change this battery to a rechargeable type. The LIR2032, I believe, is the model number of the rechargeable lithium batteries that the Sega CD uses. So make sure to not use one of these. This is the wrong battery. And you can get ones that have solder tabs to put over here too. I actually don't mind the area they put it in here. There are a few small traces, but you know, if it leaks over here, I think it's going to be a lot less damage to the board. Depending on how it leaks, I guess. It's hard to say. Like, what is a good spot for a battery to leak? You know. But yeah, get a rechargeable battery, rechargeable lithium cell, and happy hacking. This is Sega Sonic Fan signing out. Hey folks, Sega Sonic Fan here, just showing you the end of my Laseractive Repair, or rather the Sega pack for the Laseractive. And this is the proper battery you're supposed to install. It's a rechargeable battery, and that's because the SRAM controller, which is on the bottom, it's an MB3790, I believe it is, actually will send voltage to that battery to recharge it. So if you just put in a CR2032, it will eventually leak or explode, very likely, because you're shoving a voltage into it that it's not supposed to have, shoving power into it. This is the LIP2032 or 2023. You can find these online. Console 5 sells them. They're around, and they're rechargeable. That's the proper battery to put inside a Sega CD or a CDX, or in this case, a Laseractive. So make sure you do that, folks. And everything's cleaned up here and tested and working very well. I played a couple hours of Pulse Man actually the other day, which is fantastic. I love that game. And yeah, not much else to say here. I have some pictures that I took of the motherboard, some very high-res 12 megapixel pictures I'm going to be putting on my website. So if you want to see those, you can check that out over on www.segasonicfan.wix site.com/retro. I'll put that link in the description. I know it's a super long web address, but that's what it is right now. And there's a ton of cool stuff on there. I'm going to start posting more of my repairs on there, and pictures and guides and all that kind of stuff. So be sure to check that out. I don't care if you subscribe, because I don't care about YouTube. I'd rather make my own site. Eventually I'll host my videos over there once the bandwidth gets cheaper. So yeah, thanks for watching. and have fun hacking your laser actives and your Sega gear. This is Sega Sonic Fan signing out.